So this is going to be a pure CSS game. It's not got a single line of JavaScript. It's got a couple of lines of HTML, so it's not 100%, but I mean, whatever. You can count off the lines of HTML on one hand, so it's fine. And yeah, I'd like to say that I also put this together like a very last minute, and that's why the Photoshop's so bad, but I spent a long time on that, so yeah. I'm at Stephen Cook Dev on Twitter. I've linked to a slightly longer version of the game on my Twitter account, so you can go there just because some of the extra features are a bit too long to go through. But just a tiny bit more about myself. I work as a front-end engineer at a company called Thread. So Thread sell clothes online, basically. We have a load of stylists and like clever data science and stuff to like suggest you clothes and outfits that you'd like. And if you're wondering why I'm making a talk about Mario Kart, given that I work at a fashion company, yeah, let's move right along. So first of all, what is CSS? And I guess most people here already know what it is, but just as a sort of step back, just to sort of get an overall like what does it do at a high level? And basically, it's these two things. It first of all lets you select something in the DOM. So if you say p.foo, it's going to find you any paragraph tag with the class name foo. Simple enough. Next, it lets you style it. If you say background color red, it will make all those paragraph tags have a background color red. Cool. There's a few extra things that you could say don't come into this description, like pseudo elements and stuff, but it's not so important. I'm basically just sort of trying to get to the fact that this is not the correct tool for making a game, right? Like a game needs arbitrary state management. It needs controls to be able to update that state. And it needs that state to then be able to generate arbitrary content to put to the screen. None of which are the things that I just said CSS does. So why are we doing this? Part of it is just because it's fun. But part of it as well is I started out this project originally basically to sort of see how far we could push CSS and hope to learn a few things along the way, which I did in trying to do this. I think it's always a good idea when you're trying to learn something a bit better or learn something from scratch, just to sort of try something stupid and just see how far you can push it, to sort of find the boundaries of that language or tool. So we're going to start off with box shadows. Can everyone at the back read the code okay? Yep. Cool. So CSS lets you do box shadows. This does seem like a weird tangent. I promise this gets back to the game. But for now, you can specify an offset, how much blur you want, and the color of that box shadow. Cool. You can also just keep going. You can comma separate these, and you can just have as many box shadows as you like. Cool. If you go a bit further, we can also actually just specify a blur radius of 0, which means that you don't get a blurred box shadow. You just get the original box. Or if you have a box that is your div, then you just get lots of these boxes. And you can just line these up if you wanted. And I mean, while we're lining them up, why don't we just keep going and give them all different colors. At this point, we're basically just making an image, right? An image is just a collection of pixels with positions and colors. An image also has really intelligent encoding to make it performant, which this does not do. So we'll ignore that. We're not going to do this in production. But let's see if we can make something. Cool. So can everyone see this at the back? Is that OK? Yeah. I'll make it a bit bigger anyway. So this is just a file we're going to be editing. It's just going to change this page. The first thing we're going to do is basically just make this one div, and we'll call it Mario, because we want to make a Mario character. Now, the first thing we want to do is just make this div be a width and height of 1 pixel. The reason for this is each box shadow is just going to be the same size as the original element. And because we're trying to do pixel art, we want just 1 pixel sized. The next thing we want to do is specify, now the box shadow, now we want to specify all the pixels of this Mario image that we're trying to put in. So this Mario image is about 1,000 pixels big, and apparently me manually typing that out is boring. So instead, we're just going to use this Mario box shadow SCSS variable, which we are going to get from this common SCSS file. you don't need to worry too much about what this is. It's literally just a collection of CSS variables I'll use to cheat slightly throughout the talk. So if we go back now to this, you can see we've got a little Mario sprite, and I can just make that a bit bigger by saying zoom 5. Cool. So we've got a nice picture of Mario. What we can do now is if we keep going with that, I'm not going to go through the code too much here. It's all the same of what we were just seeing. It's the same thing again, but now we're just going to do it for a few more elements. So I'm going to first just make an output element. This is going to be like our screen, basically. So it's going to be the entire canvas for the game. Next, we're going to have Mario, but we're also going to have a road and some trees. Cool. So you see, got a nice little image. And that's all just the box shadow thing that we're talking about, just done in a really unperformant way. But that's boring, right? Like I said, we're going to make a game, and an image is not a game. So let's try and add some basic animation. Fortunately, CSS lets you do animation really easily. It has this animation keyword. So here, for example, we specified some keyframes that basically just say we want to go from a load of CSS properties, so like from opacity 0 to opacity 1 and a rotation. And we're specifying as well how much we want the animation to loop, so we're just saying infinite here, and how long we want the animation to last, so this is 3 seconds. You can also specify timing functions. So an example of a timing function here is the steps function. It's a bit of an uncommon one you may not have come across, but basically what it's doing, if you think about just a regular linear animation, steps one just follows the exact same overall length, but it just jumps at each step. So in steps 4, it would jump across 4 times to keep up with the linear one. So let's try and add in some animation. So if we go back here, the next thing we're going to do is just grab. So this is a keyframes that we're going to add to Mario. So I'm aware this is a bit of cheating for sort of live coding, but it's a Stack Overflow method of live coding. It's fine. So we have this driver shake, which is taking us from a scale of 1 and to a scale of 0.97. And if we get Mario to animate that, steps 2 and infinite. Basically, it's just going to get him to jump up and down from maximum height to about 0.7 height. And the reason for this, it's maybe a tiny bit subtle for people at the back, but basically just makes it look like his engine is on. It's just a nice, subtle animation. But subtle's boring. Let's do something a bit bigger. So here we've got a load of trees. So we have our 2 trees. We're actually using some pseudo elements for the left tree and the right tree. So we've got before and after for left and right. So what we can do is add in these keyframes. We have left move, right move, and fade. So left move and right move are basically just bringing in the trees to say start, shrunk down in the distance, and slowly zoom in to make it look like you're moving towards these trees. And then we also have fade, because if they suddenly jump in the distance, it looks weird, so we just fade them in as well. So if we now say tree left move, 3 seconds, infinite linear, and then we also want to, tree fade is called, right? Yep. 3 seconds, infinite linear. And then we want to do the exact same thing for the right tree, but we'll just call it tree right move. So now, cool. So you see we've got these trees coming in from a distance, so we've got a bit of movement. It does look a little weird at the moment though, right? Like at the moment, these trees are in unison. It's a bit, you wouldn't really expect that in real trees. So why don't we get them to be slightly out of sync from one another? So we can do this thing called animation delay. Say animation delay on the right tree, so it's just 1 second out, basically. And this is going to work, but if you notice the right tree right at the start, you see it just hung about for the first second because it didn't have any animation. Now it looks okay. Like now it's sort of out of sync like we wanted. But it'd be great if we could just get rid of that first initial weird 1 second hang. But what we can actually do, and it's a real easy change, they should just say -1 second. And what it's going to do is basically when the page loads, it pretends that the tree was already animating for a second. So it's out of sync, but it never actually had this delay. And a lot of people seem to think that that's like a weird hacky bit. But honestly, that is not the hacky bit of this talk. It's actually perfectly in spec. This is a quote from the W3 spec for animation delay. Negative delay is actually expected, and this one's fine to use in production. You can, get away with it. So that was a nice, simple animation. But if we want to have something like this, where we actually want our drivers to be turning, this is suddenly feeling a lot out of the realm of CSS, right? Like this isn't a rotation. This isn't. I mean, like you can't change margin left to get this to happen. So how do we get this sort of effect? And if we break down what's actually happening here, so this is a bit smaller. But if you think about that animation, you can actually think about it in terms of each single frame of what that animation was. And once you have that, you can think about like how sort of old movies work, where so old films literally have lots of different pictures, and then it runs up to say, to sort of simulate this idea of movement. And we can do the exact same thing. And if we use the steps function that we were looking at before, we can make sure that as long as we're occluding the rest of that like film that we had, then you can see on the right-hand side we've got what we want. We just speed that up. That is the animation that we want. So we need to make sure that we're occluding the entire sprite sheet. So we have all of the different pictures of Mario, but we only want to show one at a time. So we can't keep just using the div to have all these box shadows. What we need to do now is, and it's a small change, so whereas at the moment we just have our individual div, which has all the box shadows, we're going to change it slightly to say that the div now is just the width and height of the entire image, and then we're going to create a pseudo element inside of it, which is going to hold each individual pixels. So the pseudo element here is exactly what the div used to be, and the div is now just a container with overflow hidden, so that anything outside of that container is not visible. So that's a lot of talking. Let's see if we can get Mario turning. So let's copy paste some more code. So here, this is just, as I say, getting the Mario, whereas currently Mario is actually containing all of the box shadow information. Now we're not wanting him to contain box shadow information. We're just going to say that he's 50 pixels high, because we explicitly need to set that now so that we can hide everything else. But now we don't have any of the box shadow stuff in there. And we're going to get that instead from this, which is, so this, as I say, like this before element is just setting up the exact same thing as we were doing before, but it's using the sprite sheet now, so all of the pictures of Mario rather than just that one picture of Mario. And then we're going to have this sprite animate function, which is going through steps. It's going to go through however many frames there are. So we're saying that there are five frames. So we want to use that to work out how many steps of the animation we want. Otherwise, you'll get like halfway in between two frames. And we're going to go animate that between 0%. We're going to be just at the normal top. Halfway through the animation, we want to be right at the top of that sprite sheet. So we want to move it all the way for halfway. And then we want to move it back down. And the reason for this is that the animation sprite sheet is just Mario turning. So when we bring it back down again, it's him going back to neutral. One extra thing we need to do is just make sure that because before is a pseudo element, it doesn't actually exist in the DOM. So we just need content empty string and display line inline block. So it's actually there, and then width and height of 1 pixel. So if we get the page refresh now, you see we've got Mario, and he's turning, which is cool. But again, it's not a game. Games are interactive, right? Like, you can't just watch Mario turning. That's boring at best. So how do we actually get some interactivity in? Fortunately, on the web, we have a keyboard input as like a very normal thing that we're used to doing. So we can use WASD, so get A to turn left and D to turn right. And the immediate thought is that, oh, why don't we just use some CSS that basically, if we have our text box here, why don't we have some CSS that says, check for an input and see if it has value A. And if so, do something, and if it has value D, do something else. Which is a really good idea, except it doesn't work, which is a downer. And the reason it doesn't work is basically because there are two different types of values on inputs, which is a bit unintuitive. But basically, if you had some HTML where you said input type text, value equals foo. So the input loads up, it's got value equal foo, as you expect, and that's both values of foo. But if I type in bar now, this has a value of foo bar, but the attribute value of the input is still foo. So like if you were to look in inspector or something, like the value that you'd see in inspector is still foo. We could write some JavaScript that sort of syncs these things up by basically saying whenever the input changes, like just set the attribute value to match up with what our current value is. And we could do this, but I said at the start of this talk I wasn't going to do any JavaScript. And it sort of reminds me of I was moving. I helped my friends move recently, and it was one of those classic moments. You pick something up and thought, I can carry this. They said, are you sure that's really heavy? I was like, no, honestly, it's fine. It turns out they lived on the second floor, but I felt like I'd already said I'm fine, so I sort of felt like I had to stick to that. Broke a lot of things that day. But fortunately, I actually did manage to get around it on this particular problem. I found out that there are these two placeholders called valid and invalid. So these are quite uncommon. You may not have come across them. But basically, if you specify on your input, you can say something like pattern, and you can specify a regular expression here. So here we're just checking to see does the input contain the pattern of something it comes, is the text correct? And then if it is, make it green, and if it's not, make it red. So you can see I start typing in, and it doesn't meet the regular expression requirements of correct, so we get border color red. As soon as it does, though, it becomes border color green. So that's great. We've got CSS responding to text input, which is what we're going for. We can add in a third state as well, so we can have, if you use the CSS selector placeholder shown, then if your input has a placeholder, then you can say get that to override the valid and invalid attributes. So we can say placeholder shown, border color gray, state 1. Start typing, we've got our second state. Finish, and we've got our third state. So we've got 3 states, right, which is sort of what we want. We want the idea that you're not doing anything on the keyboard. That's placeholder shown. If we push D, so here our pattern is just saying anything that ends in the letter D, that's right. So we push D, and it says, yeah, that's correct, or in other words, you're turning right. If I push A, it says, you're not pushing D, so you're turning left. And this keeps working. You see we've got dynamic input based entirely on CSS. It does have a small bug. The eagle eyes of you may have noticed. If I said W, for example, it says, you're not pushing D, so you're pushing A, which, yeah. But it's, sorry? It's not the, sorry, I can't quite hear. But yeah, this is fine anyway, because users always do what they're told if you just tell them to push only A and D. So let's get that bit in. So the first thing we want to do is input type, if I can type, text. So we do actually need a placeholder, even if we don't want one. Otherwise, placeholder shown doesn't do anything. And then we want that pattern in, which is saying look for anything as long as it ends in the letter D. So that's going to get our input in, but we actually need that to be interactive. So the first thing we want to do is just make sure we have our sprite animate, but we also want sprite animate mirror. So fortunately, this picture of Mario that we have is symmetrical down the middle. So if we just literally mirror the entire animation, then rather than turning right, he'll be turning left. So now we have 2 different keyframes, one for turning left, one for turning right. The next thing we can grab is this code, which is just going to help him steer. So what this is saying is if you can find an input that's valid, then look for the Mario before element that comes afterwards and make it turn left. And if you can find one that's invalid, make it turn right. So this is exactly the same animation as what we had before. It's just, we can get rid of that now because we're doing it down here. But yeah, it's just now based on this input. And when placeholder is shown, so you haven't pushed anything, don't animate at all. So if we look at that now, you can see we've got this little input in the top left. And if I push D, Mario turns left. I push A, he turns, right and then left. But he's still very much stationary, so there's one more thing we can do, which is, so this was an animation on the before pseudo element, or the box shadows are. But now we can just do a similar thing on the container element, and we can literally just say transition a margin left. And again, if it's valid, make him go to the right. And if it's invalid, make it go to the left, which then gives the effect, if we refresh, push A, we've got Mario turning right, and A, E turning left. And we can keep this going, and we've got a nice Mario game. So there's a few bits and pieces more that you can add to this, but and I'm going to link to this on Twitter, but I'll stop now, as I'm sure no one will ever want to look at Mario Kart again. But yeah, you can find the links to that on my Twitter. Thanks very much for listening.
You know, your game looks really cool, but have you thought about Internet Explorer users over there?
Cross-browser compatibility, we're talking. Yeah, so I'll be honest, like the performance implications of the code that we're looking at, this barely works on like modern Firefox. So in terms of cross-browser, no, this doesn't. As I say, like a lot of this stuff in this talk, don't do this in production, please.
Two quick questions. What tool did you use to build actually all the pixel art that you did? Don't tell me you did it manually, otherwise.
You know, I mentioned this to someone else, and someone else genuinely thought I did it manually, and I'm insulted that people think that I do that. No, I very fortunately, I found a tool online where you can literally just upload an image, a PNG bitmap an image, and it converts it into box shadow. It's a bit of a hidden tool. I was really worried I was going to have to make it myself, but fortunately, no. If you Google about for like bitmap to box shadow converters, other great people on the internet have already made it.